1905. A small rented apartment above a delicatessen in Bern, Switzerland. A 26-year-old patent clerk pushes a baby carriage back and forth across the room, gently rocking his infant son to sleep, while his mind works through equations that no human being has ever successfully solved by day. This same man sits at a desk in the Swiss Federal Patent Office, earning roughly $600 a year evaluating other people's inventions. Gravel sorters, electric typewriters, mundane mechanical devices submitted by ordinary tinkerers hoping for a government patent. He is good at the job, he is fast at it, too. Fast enough that he has discovered something his employer does not know. If he works efficiently enough, he can finish each day's official patent examinations with hours of quiet time left over, time he spends not relaxing, but secretly doing something far stranger. He is rebuilding from first principles humanity's basic understanding of space, time, light, and energy itself. He has no university teaching position. He applied for one repeatedly for nearly 2 years after graduating and was rejected every single time. He has no laboratory, no graduate students, no institutional backing of any kind. He is, by the conventional standards of the academic physics establishment of his era, a nobody, an unemployed, then underemployed graduate with a mediocre academic record, working a government desk job that has nothing to do with theoretical physics, doing his most important thinking in the margins of his actual paid work, and in the evening hours after his wife and infant son have gone to sleep. In a single calendar year, 1905, a year historians of science would later christen his annus mirabilis, his miracle year, this anonymous patent clerk submits 4 scientific papers to the German physics journal Annalen der Physik. Any one of these 4 papers, considered in isolation, would have been enough to establish a normal physicist's entire career and reputation. Together, they fundamentally and permanently rewrote the architecture of modern physics. One paper explained the photoelectric effect, introducing the concept of light quanta and laying a foundation stone of quantum mechanics. One provided definitive proof of the existence of atoms through an analysis of Brownian motion. One introduced the special theory of relativity, demonstrating that space and time are not fixed, universal constants but are relative to the observer's motion. And one, almost as an afterthought tacked onto the relativity paper, derived a short equation relating mass and energy that would eventually become the most famous equation in the history of science. E equal to mc square. Unemployed turned patent clerk had accomplished to be properly recognized. But the foundations of 20th century physics, and, within 4 decades, the foundations of the atomic age itself, had just been laid by a man who, at the moment of his greatest intellectual triumph, did not even hold a university job. Here is the central question of this biography. How does a child so slow to begin speaking that his own parents feared something was developmentally wrong with him? A boy who dropped out of high school, failed his first university entrance exam, and was rejected for every academic teaching position he applied for after graduation, become the single most recognizable scientific genius in human history. The man whose very name became a universal synonym for genius is itself. More specifically, how does a rebellious, authority-resistant student who despised the rigid, rote memorization education system of his native Germany, a system he later explicitly blamed for nearly destroying his own natural curiosity, end up producing, in near total professional isolation, the most consequential reconceptualization of space, time, and energy since Isaac Newton? And what does it mean that this same man, a lifelong pacifist who explicitly renounced his German citizenship twice and devoted enormous personal energy to opposing nationalism, racism, and militarism, ended up, through a single, reluctantly signed letter, setting in motion the chain of events that produced the atomic bomb, a weapon whose existence he would spend the remaining decade of his life trying, unsuccessfully, to help the world contain? Welcome to Blurr. Today, we begin the incredible story of Albert Einstein, the man whose name became a symbol of genius around the world. But before he transformed science forever, Einstein was a curious child, a struggling student, and a young man repeatedly rejected by universities and employers. In Part 1, we'll explore his early years, his failures, his determination, and the remarkable journey that led him from a Swiss patent office to the frontiers of modern physics. If you enjoy this audiobook, please like, subscribe, hit the bell icon, and share your thoughts in the comments below. Now, Let's begin. Chapter 1. Origins. Ulm. In the Kingdom of Württemberg, German Empire, March 14, 1879. Albert Einstein was born into a secular, middle-class Jewish family in the southern German city of Ulm. The family relocated to Munich just 6 weeks after his birth, where his father, Hermann Einstein, and his uncle Jacob ran an electrical engineering company, Elektrotechnische Fabrik, G. Einstein and Psy, manufacturing and installing dynamos, power plants, and electric lighting systems. Among the company's notable achievements was providing the first electric illumination for Munich's famous Oktoberfest celebration in 1885. Hermann handled the business side. Jakob, an engineer, handled the technical patents and inventions. Einstein's mother, Pauline Koch, came from a comparatively wealthy family and managed the household. She was an accomplished pianist who, recognizing her son's aptitude, insisted he begin violin lessons at age 5, an instrument that would remain a lifelong source of joy and creative refuge for Einstein throughout his entire life. A child who worried his parents. Einstein's early childhood development gave little outward indication of the intellect that would later emerge. He was unusually slow to begin speaking, to the point that his parents genuinely feared he might have some form of developmental impairment, a detail that has since become one of the most frequently cited, almost mythologized aspects of his early biography, often invoked as an early example of how unconventional minds can be misjudged by conventional developmental standards. Einstein himself later identified 2 specific early childhood experiences as having left a profound and lasting impression on his developing intellectual curiosity. The first occurred around age 5, when his father showed him a magnetic compass. Young Albert was utterly mystified that an invisible force could reliably deflect the needle, regardless of how he turned the device. His first encounter with the idea that unseen forces govern the physical world, an experience that planted what would become a lifelong fascination with the invisible structures underlying visible reality. The second was his encounter, a few years later, with a small book on Euclidean geometry, which he later described as a kind of revelation. The discovery that pure human reasoning, beginning from a small set of self-evident axioms, could produce certain, logically airtight conclusions about the structure of space itself. A fractious pupil in a rigid system, Einstein attended a Catholic elementary school in Munich, despite his own family's Jewish background, a reflection of the relatively limited educational options available in their immediate neighborhood, before enrolling, at the standard age of 10, in the Luitpold Gymnasium, a secondary school run on the strict, authoritarian, rote memorization educational model common to the German Empire's school system of the era. Einstein hated it. He found the school's rigid disciplinary structure and its pedagogical emphasis on memorization over genuine understanding fundamentally suffocating to his own naturally curious, independent-minded intellect. He later wrote explicitly and repeatedly that he believed this kind of strict rote-learning educational philosophy was actively harmful to genuine creativity and independent thought, a conviction that would shape his lifelong skepticism toward rigid institutional authority of every kind. Not merely educational. A family business collapses, and a boy is left behind. Company lost a major bid to supply electric lighting infrastructure for the city of Munich. The family business lacked sufficient capital to upgrade their technology from the increasingly outdated direct current, DC, systems to the more modern, efficient alternating current, AC, alternative that competitors were beginning to offer. The failure forced the family to sell their Munich factory and relocate, first to Milan and then to Pavia, Italy, in search of new business opportunities. Einstein, then 15, was left behind alone in Munich, boarding with relatives, in order to complete his secondary schooling at the Luitpold Gymnasium, a school he despised, now without the daily presence of his immediate family for support. The isolation, combined with his already simmering resentment of the school's authoritarian structure and his looming dread of mandatory military conscription once he turned 16, proved unbearable. Within months, Einstein secured a doctor's note, citing nervous exhaustion, that allowed him to formally withdraw from the gymnasium without completing his diploma. He left Munich and rejoined his family in Italy, arriving unannounced and uninvited. A school dropout, and, in the eyes of uninvited German authorities, a draft evader with no diploma and no clear professional prospects. His parents, understandably, were deeply concerned about what kind of future awaited a son who had abandoned his formal education and fled the country of his birth specifically to avoid military service, a failed exam, and a second chance. Einstein spent the following months in Italy, largely unsupervised, hiking, reading philosophy, playing his violin, and visiting museums. By his own later account, one of the genuinely happy, intellectually nourishing periods of his adolescence, even as it represented, from any conventional vantage point, a young man drifting without direction. Eventually persuaded that he would need to acquire a formal profession to support himself, Einstein applied directly to the prestigious Swiss Federal Polytechnic School in Zurich, skipping the normal secondary school diploma requirement by sitting for the institution's entrance examination directly. 2 years younger than the typical applicant, he failed the exam. His scores in mathematics and physics were exceptional, genuinely outstanding by the examiner's own assessment, but his performance in other required subjects, including languages and general academic coursework, fell short of the admission standard. The director of the Polytechnic, recognizing the boy's obvious aptitude in the sciences despite his overall exam failure, recommended that Einstein complete his secondary education properly first, suggesting a more progressive Swiss cantonal school in Aarau, run by Jost Winteler, an educational environment built on principles of independent thinking and student autonomy that stood in sharp, welcome contrast to the rigid German gymnasium system Einstein had fled. Einstein flourished at Aarau, completing his diploma in 1896 with excellent grades, contrary to a popular but inaccurate myth propagated for decades afterward, that Einstein had been a poor student throughout his entire education. He was, in fact, an excellent student in precisely the subjects that mattered most to his eventual career. His struggles were specifically with the rigid, authoritarian style of instruction itself, not with the underlying material. That same year, in a deliberate act of youthful rebellion against the country whose rigid educational system and looming military conscription had so alienated him, Einstein formally renounced his German citizenship, becoming stateless for the next 5 years until he successfully acquired Swiss citizenship in 1901. Chapter 4. Early Struggles. A mediocre student at the Polytechnic. By his own account, Einstein enrolled at the Swiss Federal Polytechnic School in Zurich in 1896, intending to train as a secondary school teacher of mathematics and physics. While unquestionably brilliant in the specific theoretical questions that genuinely interested him, Einstein was, by his own candid, later admission, and by the assessment of several of his professors, an inconsistent and at times frustratingly independent-minded student, frequently skipping lectures he found uninteresting or insufficiently rigorous, relying heavily on the meticulous lecture notes of a close friend and fellow student, Marcel Grossmann, to pass required examinations in subjects that did not personally captivate him. This pattern of selective, independently directed intellectual engagement, intense focus on what genuinely interested him, near total disregard for what did not, would remain a defining characteristic of Einstein's mind for the rest of his life. It served him brilliantly when applied to fundamental theoretical physics. It served him considerably less well in the conventional, credential-focused academic environment of the Polytechnic, where his evident disregard for certain professors' authority and expectations left a lasting negative impression, with consequences that would soon become painfully clear: a daughter born in secret and a marriage delayed. During his time at the Polytechnic, Einstein fell deeply in love with a fellow physics student, Malaya Moric, one of remarkably few women studying physics at the THAL university level anywhere in Europe at the time, and a serious, gifted student in her own right. Einstein's parents, particularly his mother, strongly opposed the relationship, partly due to Moric's Serbian Orthodox background, in contrast to the Einstein family's Jewish heritage, and partly due to broader family concerns about the seriousness and practicality of the match. The couple had an illegitimate daughter, Liesel, born in early 1902, before they were able to marry, a daughter about whose ultimate fate historians still know remarkably little. She may have died in infancy from scarlet fever, or may have been given up for adoption, with the historical record remaining genuinely unclear and a continued subject of Biographical investigation. Einstein and marriage. Finally married in January 1903, after Einstein had secured steady employment. Graduating into unemployment, Einstein graduated from the Polytechnic in 1900, formally certified as qualified to teach mathematics and physics at the secondary school level. What followed was a genuinely difficult and professionally humiliating period that does not fit comfortably into the popular mythology of Einstein as an instantly recognized genius. He spent nearly 2 full years unable to secure any stable academic teaching position whatsoever, despite extensive applications to universities and secondary schools across Switzerland. Part of this difficulty appears to have stemmed directly from the strained relationships Einstein had developed with several of his Polytechnic professors during his student years, professors whose good opinion and willingness to write strong letters of recommendation mattered enormously in the tightly networked, reputation-dependent world of European academic hiring, and whose support Einstein's independent-minded, occasionally dismissive classroom demeanor had not exactly cultivated. Through a patchwork of temporary tutoring positions and substitute teaching assignments, unstable, poorly compensated work entirely unworthy of his actual intellectual capabilities, but the only employment available to a freshly graduated physicist with an uneven academic reputation and no institutional patron willing to vouch for him. The compassion of a friend's father. Einstein's professional fortunes finally turned not through his own academic credentials, but through personal connection. Marcel Grossman, the classmate whose meticulous lecture notes had helped Einstein pass his own university examinations, had a father with personal connections to the director of the Swiss Federal Patent Office in Bern. Through this introduction, Einstein secured an interview and, in June 1902, a position as a technical expert, Class 3, at the Patent Office, a stable, if modest, government position with an annual salary of approximately 3,500 Swiss francs, roughly 100 Swiss francs, equivalent to the $600 figure historians later cited in American terms. It is worth pausing on the genuine improbability of this outcome. The man who would become the most famous physicist of the 20th century secured the position that enabled his most important scientific breakthroughs not through any formal academic channel, but through a friend's father's personal favor. A reminder of how often genuinely transformative intellectual contributions emerge from outside, rather than through the conventional credentialing systems meant to identify and cultivate talent. His father, Hermann Einstein, would not live to see what his son eventually accomplished with this position. Prematurely aged by years of repeated business failures and financial strain, Hermann died in October 1902, just months after Einstein began his new position at the Patent Office, deeply in debt to a wealthy relative, a final, painful family hardship that Einstein carried into the period of his greatest scientific productivity. Chapter 5. First success. The best department of physics in Europe. The Swiss Patent Office position, modest and unglamorous as it initially appeared, turned out to be an almost perfectly designed incubator for the kind of independent, unconstrained theoretical thinking that would define Einstein's greatest work. The job itself, evaluating patent applications, identifying the essential technical claims of each proposed invention, and rewriting unclear descriptions into precise technical language, suited Einstein's analytical mind well, and he became genuinely proficient and efficient at it, earning a permanent position in 1903. Crucially, Einstein discovered that he could complete his official patent examination duties quickly enough to leave substantial quiet time during each workday for his own independent theoretical physics research. Work he conducted, by his own later account, in a desk drawer he could quickly close whenever a supervisor approached. One of Einstein's earliest biographers would later remark, with a degree of admiring irony that has since become a frequently repeated observation about this period, that the drawer in Einstein's Bern Patent Office desk, where he secretly kept his physics papers, was effectively the best department of physics in Europe at the time, a small, anonymous government office drawer containing work that would soon eclipse the output of every formally credentialed physics department on the continent. Einstein later reflected with genuine appreciation, rather than resentment, on this unconventional incubation period. The work on the final formulation of technical patents was a true blessing for me, he wrote. noting that the discipline of evaluating other inventors' claims with absolute technical clarity and precision had itself provided valuable inspiration and rigor for his own physical theorizing. 1905. We have already witnessed the culmination of this period. The 4 papers Einstein published in 1905, while still working full-time at the patent office, that collectively reshaped the foundations of modern physics. The photoelectric effect paper would, years later, earn him the Nobel Prize. The Brownian motion paper provided rigorous physical proof of the existence of atoms, a question that had remained genuinely scientifically contested up to that point. The special relativity paper demonstrated that the speed of light is constant for all observers regardless of their own motion, a finding with the radical implication that space and time themselves are not fixed, universal absolutes, but are relative, varying depending on an observer's own velocity. And the brief follow-up paper deriving the mass-energy equivalence relationship would eventually produce the single most recognizable equation in the history of science. The papers did not produce instant global fame. That recognition would take years to fully develop, requiring experimental confirmation and the gradual absorption of these radical ideas by the broader physics community. But among a small circle of the era's most serious theoretical physicists, the papers were recognized almost immediately as work of extraordinary, field-redefining importance. Max Planck, himself one of the founding figures of the emerging quantum theory, was among the very first established physicists to grasp the full significance of Einstein's work, and it was Planck who, roughly a decade later, would personally help recruit Einstein to one of the most prestigious physics positions in the world. Slowly, belatedly entering academia, Einstein obtained his PhD from the University of Zurich in 1905, the same extraordinary year, based on a dissertation related to his Brownian motion work. He continued working at the patent office for several more years even after the significance of his significance. 1905, papers began to be recognized within the physics community, finally securing his first formal academic position as a private docent, an unsalaried lecturer position common in the German academic system, at the University of Bern in 1908. From this point forward, Einstein's academic career, having taken nearly a decade longer to formally begin than his actual scientific genius warranted, finally began to accelerate rapidly. A professorship at the University of Zurich in 1909, a position in Prague in 1911, and in 1914, an extraordinary offer that few physicists of any era could refuse. The directorship of a new physics institute in Berlin, combined with membership in the Royal Prussian Academy of Sciences, widely regarded as the single most prestigious physics position available anywhere in the world at that time. Einstein, despite his deep and long-standing personal distrust of German militarism and nationalism, sentiments that had driven him to flee the country as a teenager, ultimately accepted the Berlin position. He arrived in Germany just as the continent plunged into the catastrophe of the First World War. Chapter 6. Major failure. Unlike several of the entrepreneurs and political figures profiled elsewhere in this biography series, Einstein's career does not contain a single dramatic financial collapse or public humiliation that functions as a clean major failure chapter in the conventional sense. His central failure was different in character, a profound, lifelong, and ultimately unresolved moral struggle between his deeply held pacifist convictions and the catastrophic, world-altering consequences of a single letter he reluctantly agreed to sign. The letter he reluctantly agreed to sign. He could never take back. In the summer of 1939, with Europe sliding inexorably toward another world war and Adolf Hitler's Nazi regime firmly entrenched in power, the Hungarian-born physicist Leo Szilard, who, along with fellow émigré physicists Edward Teller and Eugene Wigner, had fled Nazi-controlled territory for the United States, became gravely concerned about a specific and terrifying possibility. Groundbreaking discovery of nuclear fission might be racing to develop an atomic weapon for the Nazi regime. Szilard and his colleagues recognized that they needed someone with sufficient scientific stature and personal credibility to capture the attention of the American government. and there was only one plausible candidate. On July 12, 1939, Szilard and Wigner drove out to Long Island, where Einstein was staying for the summer, to explain their fears directly. Einstein, who had not previously considered the destructive military potential of nuclear fission, was startled by the implications. "Daran habe ich gar nicht gedacht," he reportedly replied. "I did not even think about that." After a second visit from Szilard and Teller, Einstein dictated and signed a letter addressed to President Franklin D. Roosevelt, warning that recent nuclear fission research raised the genuine possibility of an extremely powerful new type of bomb, and that Nazi Germany might already be pursuing exactly such a weapon. The letter, finally delivered to Roosevelt in October 1939, prompted the president's now famous response to an aide. "This requires action." That action would eventually become the Manhattan Project, the massive, secret scientific and industrial undertaking that would produce, by the summer of 1945, the first functional atomic bombs in human history, excluded from the very project he had set in motion. In a bitter and historically significant irony, Einstein himself was never invited to work on the Manhattan Project he had helped initiate. Declassified FBI files would later reveal the precise reason. American military and intelligence officials, aware of Einstein's lifelong, well-documented associations with pacifist and socialist political organizations, deemed him a security risk unsuitable for access to the nation's most sensitive military secrets. He was denied the security clearance that would have been required for direct involvement, and instead spent the war years performing unrelated theoretical consulting work for the U.S. Navy and auctioning off personal manuscripts, including a handwritten copy of his original 1905 special relativity paper, which was sold for $65 million to support the broader war effort indirectly. Einstein learned that an atomic bomb had actually been detonated over the Japanese city of Hiroshima while on vacation in August 1945. By multiple accounts, his reaction was 1945. Simply a horrified whisper. "Oh my God," a regret he could never fully resolve. For the remaining decade of his life, Einstein grappled openly and publicly with the moral weight of his role in setting these events in motion. In a 1947 interview with Newsweek magazine, he stated plainly, "Had I known that the Germans would not succeed in developing an atomic bomb, I would have done nothing for the bomb." As it turned out, the wartime exodus of Jewish and politically endangered scientists fleeing Nazi persecution, Enrico Fermi, Emilio Segre, Rudolf Peierls, Felix Bloch, and many others, had so thoroughly depleted Germany's own theoretical physics talent pool that the Nazi nuclear program never came remotely close to producing a functional weapon, a historical irony Einstein could not have known when he signed the original 1939 letter. According to physicist Linus Pauling, Einstein expressed continued regret about the letter for the rest of his life, even while maintaining that, given the information available to him in 1939, a world in which a Nazi-developed atomic weapon seemed like a genuine and existential threat, he could not honestly say he would have acted differently if faced with the same uncertain choice again. This unresolved tension between his sincere, deeply held lifelong pacifism and his unavoidable historical role in initiating the development of the most destructive weapon ever created represents the central, defining moral failure and tragedy of Einstein's life. Not a failure of intellect or courage, but a failure shared by an entire generation of scientists and statesmen to find any way of preventing humanity's most catastrophic scientific possibility from eventually being realized once the underlying physics had been understood. We'll discover how Einstein became the world's most famous scientist and explore the legacy he left behind. Audiobook. Please support Blurr by liking this video, subscribing to the channel, and hitting the notification bell. And don't forget to leave a comment. What part of Einstein's early life surprised you the most? Thank you for listening to Blurr.